All right, so in this video, we are going to divide numbers. All right, we're going to divide complex numbers. And first thing I want to mention here is fractions. So let's say you wanted to do 6 divided by 3. I mean, obviously you know the answer, but let's say division didn't actually exist. It does. All right, I'm not trying to burst your bubble here, but is there another way to divide 6 by 3 without division? All right, is there a way to do it using subtraction or addition or multiplication? So let's see here. I guess one way that you could divide by 3 is actually just subtract 3 until you get to 0. All right, so 6 minus 3 is equal to 3, and 3 minus 3 is equal to 0. And we had to do that 2 times. So the answer is 2. Maybe that works. Let's try using addition. All right, so we can't do 6 plus 3. I wonder if we could do 6 plus 3 until we get, twice as much as 6. So let's say we're stopping at 12. Well, here we go, 2 times. I mean, this is pretty unofficial. I'm just kind of making this up as I go. But another popular way that you can think of division, a good way to think about division, is in terms of multiplication. So instead of dividing by 3, what you can do is 6 times the multiplicative inverse of 3. Now, I know you haven't heard that word for a while. The multiplicative inverse of 3 is going to be 1/3. It's reciprocal is what it is. So 6 times 1/3. But, I mean, this technically is correct, and it will give you 2. But, I mean, how do you even evaluate multiplying by 1/3? You're going to use division to do it. But what we're doing today, it's a little like that. I mean, we're dividing, but in order to divide these, we actually have to multiply. So what we're going to do is we're going to multiply by the conjugate of the bottom. All right, we're going to multiply top and bottom by the conjugate of the bottom. So remember, the conjugate is just it's just where you change that middle sign. So it's 4 minus 2i. And we're also going to multiply the top by 4 minus 2i. All right. So let's see what happens here. 4 times 4 is going to give us 16. 4 times negative 2i is negative 8i. So I'll just write that down here. And then 2i times 4 is positive 8i. So those just cancel each other out. And then we're going to have 2i times negative 2i. Well, that is negative 4i squared. And remember, the I squared, just it changes the sign out here because I squared is equal to negative 1. So negative 1 times negative 4. You wind up with a plus 4 on the bottom. Up top, let's multiply this out. Negative 4 times 4 is negative 16. Negative 4 times negative 2i is positive 8i. 28i times 4, 112. 112i. And then 28i times negative 2i. Well, that's negative 56i squared. So it's a plus 56. All right, let's simplify some stuff here. I'm just going to go work vertically. In the bottom, I'll do that part for you. 20. Up top, let's combine negative 16 and 56. That's 40. And then 8i plus 112i is 120i. Now, you might be asking, what did we just do? And that's okay. So what we did was we divided this one by this one, and all this actually does, and the main goal is to make the denominator. The goal was to get this denominator as a rational number, as a number without any imaginary parts. So to do that, we multiplied top and bottom by the conjugate. There's actually one more thing we can do. You see how all three terms, this one, and the bottom, all of those can be divided by 2. They can be divided by 4. You want to divide them all by the greatest common factor. So I'm just going to take it in steps here. Let's say you divided them all by 4. The 40 would become a 10. The 120i would be a 30i. And the 20 would become a 5. I forgot what we were dividing by. Now, all three pieces can be divided by 5. So our final answer here is a 2, a 6i, and a 1. So really, we don't even need that 1. That's our final answer. 2 plus 6i. Boy, that was magical.